Hello everyone, welcome to the today's lectures on Unit 3rd of Deep Learning. I'm Kamlesh Raghuvanshi, and in this session we are going to understand the core concept of CNN and optimizers, popular CNN architectures, and regularization techniques. So, uh, convolutional neural network convolutional neural network, commonly called CNN, are specially designed neural network for processing image data. Unlike the traditional neural network that treat the input as a simple vector, CNN understand the spatial structure of an image, the pattern, the shape, the texture. These are the graphical representation of the CNN. Here you can see these divided into the two part. The first part is known as feature extraction, and second part is known as classification. So here we treat image as an input, then second layer called convolutional layer, and second layer is called pooling layer, and third layer is called fully connected layer, and here is the output. So now uh, here we discuss how the CNN work. So let us understand how the CN actually work. So first, convolutional layer, these are the core of the CNN. These apply to learn, filter or kernel across the input data like an image, detect specific features such as age, textures or the shape. These are the work of the convolutional layer. Mainly the convolutional and pooling layer are used for the features detection from the image, or we can say they extract the required features. Uh, now the pooling layer, these layer reduce the spatial dimension like a bit the height of the data, which helps to make the model more computationally efficient. Now here we use the activation function like uh, ReLU, and next layer is a fully connected layer. After the convolutional and pooling layer have extract the feature, these layer take the high level feature and use them to make the final classification or the prediction. Mean that they extract the features, and then these features converted into the flattened form, and then these flattened form input to the fully connected layer. Now here, after the CNN, we discuss some optimizers. In a previous unit, we have also discussed these optimizer like a gradient descent algorithm and its type. So now here we discuss some advanced form of these descent, these required in the CNN. Advanced optimizer in the deep learning are algorithm that adjust a neural network parameter weight and learning rate to the minimize the loss function more efficiently than basic method. uh, Here the basic method is called gradient descent. These are the advanced form of the gradient descent. Here first SGD with momentum. Here we use in the SGD we add some momentum with stochastic gradient descent. Stochastic gradient descent is the type of the gradient descent. Now, in form of advanced optimizer, we add some momentum because the SGD sorry GD gradient descent is gradient descent working is slow, so now we add some momentum with gradient descent, so we finally reach on the global minima uh, on a less time. So next, Nestrobe accelerated advanced optimizer, adaptive gradient descent algorithm, and RMS probe. Full form of the RMS probe is the root mean square propagation, or then next is the adaptive moment estimation. These are the five types of advanced optimizer. These optimize your weight and learning rate so we can achieve our global minima easily and fastly. So now, different these are the important part of the CNN. CNN is a neural network architecture in the deep learning used to recognize the pattern, form, structure, array. Over many years, CNN architecture and many variant of the fundamental CNN. This been developed, leading to an amazing advance in growing deep learning field. Here we discuss different types of CNN architecture. First is LeNet 5. LeNet 5 architecture. In 1998, these are the billing case of that time. Uh, LeNet, the first LeNet 5. 5 architecture is the most widely known as CNR architecture. It was introduced in 1990s, widely used for handwriting method digital recognition. In it is used first time in 1998, or you can say these are the winning case of that time. So LeNet 5 has two convolutional layer and three fully connected layer. You can see in the diagram here we use input is a image. These are the black and white image. So the image size, or you can say the input size is 32 into 32 into 1. The one shows these are the black and white image, because here only one slide you can use as an input. So these are the convolutional layer. Then after the convolutional operation, we can apply average pooling. So after these are the first convolutional layer, and these are the second convolutional. After that, the output of the average pooling converted into the flattened form. These flatten are input to the fully connected layer. Or you can see here these are work on the 60K parameters. These are the advancement of the deep learning. And here we can discuss the next CNR architecture is called LXNet. LXNet architecture won the 2012 ImageNet ILS VRC challenge. You can say these are the winning case of 2012 challenge of a deep learning algorithm by a large variance by achieving 70% with the top 5 error rate. As a second best achieved is 26. It was introduced by Alex and name of founder, and the other name is Elia, uh, and quite similar to the Linet model. Instead of stacking pooling pooling layer top of each on CN network. Okay, now you can see the architecture of the LXNet here. The input, you can see here the image as an input. The image size is 224 into 3. This shows the image is a colored image. Now here first we apply the convolutional operation, or the filter size of the convolutional operation is 11 into 11, and here we can use the max pool. The pooling filter size is 3 by 3. Then next we can use convolutional and max pooling, and third time we can also use the convolutional operation of filter size 5 cross 5 and max pool 3 cross 3. Here we can use the fully connected layers. There are three fully connected layers. First is four input is 4096. Second also full 4096 too, and last is the 100 with 100 inputs. And here we can use the softmax function. Now let us see the next architecture is called ResNet or residual architecture. These are the winner case of ILS VRC 2015 challenge was developed by the Camming. He delivered an impressive top 5 error rate. Here the error rate is 3.6. So these are the best architecture, and extremely deep CNN composed of 152 layers. Now here you can see we can use 152 layers total, convolutional and fully connected layer. And the essential factor enabling the training of such deep network is the use of skip connection. Yes, this is the important part of the here we can use the skip connection operation. Okay, now let us see the architecture of the ResNet, and finally here we discuss the regularization technique. Regularization is the important technique used in the machine learning and deep learning to prevent overfitting. Overfitting is the kind of challenge in the machine learning and deep learning, and which now again you can see which otherwise cause model to perform poorly on unseen data. Mean that your model proper work on the training data, but properly not work on the testing data. So here how can while regularization we can remove the problem of the or the risk of the overfitting. So here mainly two types of regularization technique we have used. First is L1, and second one is L2. So in L1 we can uh, it adds the absolute value of magnitude of the coefficient as the penalty term to the loss function. So here we add the penalty term uh, with the loss function. So why this? We can improve the value of the weights, value of the weights. Or in a L2 we can add the penalty term with a loss function uh, with the square of the weight function, square of the weight. So these are the thank you.